All right, yay. So the open review session is officially open. So any questions, let me know, and we'll make sure everybody's good to go for exam number 3. Sorry, exam number 4. Yep. One of the things that I want to make sure that we are aware of. So these 2 questions here are literally your entire exam. So your entire exam is going to be made up of these 2 types of questions. So the first one is going to be on the confidence intervals, where you have to give the point estimate by itself and then the point estimate plus or minus that range that'll give you whatever confidence I'm asking for, and then I'll have you do that again for a second confidence interval. For the ANOVAs, effect size it's good to know about, but it's more of a second semester kind of thing in statistics. So this is literally what you will be asked to do. So for the null and the research hypothesis, I will give those to you. Those will be written out for you in the question. You need to find your between and within degrees of freedom. Put down the alpha level that we have in the question. Find your p-value. Determine whether that accepts or rejects the null and the research hypothesis. And then for the post hoc analysis, I will ask you specific comparisons. Like, is this sample or is this population different than this population? Is this population different from that population? And then your task will be to find that output and then determine whether or not it's a significant difference or a non-significant difference. And it will literally be like probably 4 and 4 for each, 4 confidence intervals, 4 ANOVAs, and that's it. So nothing beyond what you see on those 2 template questions. All right. Shannon, what do you want to see? Okay. Anything in particular or just? One. Okay. Well, let's try this one in the template over here. Okay, so let's assume that these are, we'll do it both ways, but we'll assume that it's a dependent design first. So in this case, we have 9 subjects. They get measured under X conditions. They get measured under Y conditions. And then here is one of the first things that we need to see is what is the confidence interval trying to estimate. And it's either going to try to estimate an absolute amount, how much of something is there,
the
whole amount, or it's going to ask you for the difference. Those are the only 2 things that it can ask you for. So for this one here, it goes, how much higher is group X than group Y? That's asking for a difference, right? A separate confidence interval could ask you something like, how large is group X, right? Or how high are the scores for group X? So be on the lookout for that kind of language.
If it's less, is it negative?
If it's asking how much less is group X than group Y, you still want a positive number because that's how much less it is.
Okay.
And I will not give you something where it's a decrease and it's asking you to estimate the increase.
Okay.
So the correct thing would be to say that there is a negative increase, because if there's a decrease and I'm asking you to estimate the increase, then it's a negative increase. That's technically the case, but I'm not going to do that because I think that's just mean. But, when it asks for like how much lower were the scores, if they're 5 points lower, you have to estimate 5 points. If the only thing that I can imagine that we would where it might be a negative is if I ask you for the change and it decreases, then it's a negative change. You need to say, yeah, the change was -5. But if I ask you for a decrease, it's kind of like saying, how much does this cost? You're not going to say, well, it's going to be -200 to you. You just say, 200 or whatever. But first thing you need is to know whether you're looking for that difference or you're looking for the absolute amount. So in this case, we're looking for the difference. So once you know that, and once you know what you, the test that you want to run, we're going to pop this into SPSS. So we can go back here. Let's get rid of these guys. And put the first one, and that was, let's call that blah X. And then, whoops. And then the second one goes into the same row, second column, because this is a dependent means. Right, and that is blah Y. All right, so then in order to start the calculation, we just do a t-test. So we go to compare means. This is a paired samples t-test. We set it up, and don't spend too much time thinking about which one should be which, because I forget this at least 12 times a semester. But we'll set it up where we have blah X as one, variable blah Y as another. And then here in the options, this is where you need to set your confidence interval. So for this first one, they are asking for a 95% confidence interval. We got that 95% there. That's the default. So we're all good to go. We hit continue. We hit OK. And then this is the information here that we have for our 95% confidence interval. Now, we're asking for a difference here, right? We want to know how much higher is group X than group Y. And notice we just happened to luck out this time. So you can see there, it goes blah X minus blah Y. So if group X is higher, we're going to end up with a positive number there, right? Because we're going to have a bigger number for blah X minus a smaller number. That'll be a positive number. And lo and behold, the mean difference that we have right there indicates that we've gone in the right direction. So if that number was a negative, indicating that the decrease was negative, meaning that it's an increase, that you don't want to deal with. But here we have a positive number, so that makes sense. So that's our first answer to how much higher group X is. That's our point estimate. So we got 3.77778. So let's just pop that whole thing in there. So we got 3.77778. All right, and that's your point estimate. And then that is the point estimate for every single confidence interval that we're doing. So it doesn't matter how confident we want to be, it's always going to be around that center point. Mm-hmm.
So do you don't round those, you just put in whatever it says?
Well, you are going to be graded to a certain number of decimal places, a certain number of significant digits, but if you have more than that, it's not going to be an issue. And I highly encourage just copy the whole value from SPSS, because I've seen too many students round incorrectly, and I know they're doing it in their head, and it's just super easy to make a mistake. So I'll put the whole value in there. So now we got our point estimate. So now we have to find out those arms. So the way that I typically would do this is you have your center, which is at 3.78. That's your point estimate. And then we go to those two numbers there, 95% confidence interval of the difference. They tell you your lower amount. So that's at minus 3.95. And then they tell you your upper amount, which is at 11.50. And then you need to find the arm length, right? That's the final number that you need. And the easiest way to do that, and it'll work every single time, is if you take that upper value.
So every single time you take the upper minus?
Yeah, I mean, there's literally 3 ways that you can do this. 0067. 0067. If you take that minus your center point, your point estimate, that will give you the length of the arms every single time.
Okay.
So you can take this minus this, or you can take this minus this,
okay,
or you can take this minus this divided by 2. There's a number of different ways, whatever way kind of makes sense to you. But I just go, because I'm in the habit of it, upper minus middle. It'll always work out. Even if you have negative numbers,
That's what I think.
it'll still work out. So even if this was completely negative and completely reversed, in that case, this would be positive, this would be negative, and this would be negative. So we would have 3.9, that was 94, what was that output? 94512, 3.94512. And if we had that minus -1 times this, that's the mental gymnastics I'm talking about. You can see it's the same number there.
Okay.
But that's what you need to do for that portion there, for that arm. So then the only other thing that we need to do is we go back into SPSS, we go back to the data here, we go back to analyze, compare means. We're still doing that pair samples t-test. Everything is set up. The only thing we need to do is go back to those options and change that confidence interval now to the next one that we're asking for, which is 99. We hit continue, we hit OK, and we got our 99% confidence interval of the difference. And now our upper is 1509. So we pop that into here, 1509, minus, once again, that center, and that's the arm for the 99% confidence interval. And as a quick check, if you're doing it correctly, the higher your confidence, the bigger that arm should get. So your point estimate should be the same all the way down. And then you can see here our 95% confidence interval is smaller than our 99% confidence interval. That should be the case. So if you find that it's not, something went wrong, and you should go back and check it out.
Was there, I feel like there's an example when it was like it crossed the mean. Remember that?
One that,
It was like when it doesn't matter that it's negative or.
well, the negative thing, that's going to be less of a calculating a thing about calculating it. It's more about what the confidence intervals mean. So we covered that we looked at that when we were introducing, when we were introducing confidence intervals, just to kind of let you know what it means. So let's say that somebody was asking you, is group X higher than group Y? So for these scores here, can you tell me how much higher is group X than group Y? Well, if that's all that they want, that's your point estimate. So you would say, all right, it's 3.78.
Okay.
They were 3.78 scores higher. If they say, all right, I want you to be 95% confident about that, well, then you would say, all right, well, it's 3.78 plus or minus at 7.7. So the maximum that you can estimate, or that you would estimate, where group X is bigger than group Y, is 11.5 if you're 95% confident. The key here, though, is that the minimum that they're better than group Y is going to be minus 3.95.
Okay.
So in this case, this interval, this 95% confidence interval, you are 95% confident that the difference between group X and group Y is somewhere in here. But notice somewhere in here is zero difference. That means that you cannot be 95% confident that group X is bigger than group Y, because your 95% confidence interval also has this one where group Y is bigger than group X. So that's what we looked at. That one came up in the memory example, where the overestimation of the speed also included a negative number, meaning that they might have underestimated the speed. And what that means is that you cannot be sure with that level of confidence that they overestimated the speed.
Okay, that makes sense.
If this 90% confidence interval didn't cross into the negatives, then we could say, oh yeah, we're 95% confident that it's an increase in the X category. It might be over here, it might be over here, but we're 95% confident that whatever it is, it's an increase.
Okay.
Over here, we're not 95% confident. And it actually, let's see if we can just We'll run this one more time. So analyze, compare means, paired samples t-test. If we go to options, let's drop this down to 80. Let me hit OK. Still, even with 80, you'll notice right there we have that, still that negative lower bound. So if we do this one last time, whoops. Let's drop this down to 70. All right, finally.
Okay.
We're now at the point where even the lower bound, even our lowest estimate of how much higher group X is, now it's finally in the positive area.
Okay.
So we can be 70% confident that group X is bigger than group Y. But that's it. That's about as high as we can have a confidence on this, this one.
Thank you.
Yeah, no problem. And then for the other way to do this, if this was an independent means t-test, so from the description you were like, okay, this is an independent means t-test, then what you would do is you would have your scores here, and then you would label them. So these guys would be the X, and then we would put our Y scores right underneath. So if these were two different sets of 9 subjects each, whoops. Then we would go to analyze, compare means, independent samples t-test. Your test variables are your scores, your grouping variables is your group. This one we got to define our groups. So in this case we would have X and we would have Y. We hit continue, and once again we go to options here, set our confidence interval to whatever it is that we need to put it as, hit OK, run it, and then now again we have this confidence interval of the difference. And you'll notice that for 95% confidence interval, we got way different numbers. Mm-hmm. So we now have the same point estimate, right? So the point estimate is not based on any sort of comparison distribution. That's just the differences between your two samples. So that hasn't changed, but now we have our lower bound here at minus 6.47. You now got the upper bound all the way up here at 14.03. And then we would put in that as a point estimate, and still this minus that will get you your arms. All right. And then are you solid on the one sample confidence interval, how to run those?
I had a question about that. I know how to do it. I just got confused on one of the lectures you had said, I think it was adding the hypothesized mean back in.
Yep.
But you don't have to do that if you go back and enter the something at 0.
Yeah.
That's value at 0.
Yes. Yep.
So as long as you know the difference between adding the test value as what's in the problem or 0.
Let's do one.
Yeah, let's do one. So let's say that we had.
Because now I'm like, wait, what? Please just do
so let's take those scores right up there, and let's say that was some measure of self-esteem, right? And let's say that I was working with a school, and they told me that last year they measured their students' self-esteem on this self-esteem test, and that self-esteem test, wrong one, that self-esteem test came back, and the population of their students had a 65. And then they wanted me to implement some program to increase the self-esteem of students. And I did so. And now I want to come back and say, hey, look, your students have improved. Your students are better. So they want to know if those are the self-esteem scores for the students now after my program, they would want to know how much higher is the self-esteem than it used to be. So this is an example of one where they're asking for a difference. They're asking for how much higher is the amount. So if you have that, if you have a difference that they're asking for, then you want to put in your null hypothesis. You want to put in that hypothetical mean. So for this one, if we go to analyze, compare means, one sample t-test, we have our scores as the test variable. And then for the test value, we have to put in that self-esteem that they had last year, which is 65. So then we go to options and we put in our confidence interval percentage. And you'll notice that when the results come out here, we have a mean difference of 11.2. So that 11.2 is our estimate of how much higher their self-esteem is this year. That would be a horrible self-esteem if that was their level. So that's not their level, that's how much higher it is. And then the upper bound is this program may have increased their self-esteem all the way up to 16 points more, or it only may have increased their self-esteem by 6 points more, but we are 95% confident that it's somewhere in between there. So that would be your point estimate, and then this, you would find for your the length of your arms. Now, on the other hand, if somebody came by and didn't know about the program, didn't know about anything that we did, didn't know about the students last year, and just came and said, well, how much self-esteem do your students have? What's their level of self-esteem? In that case, they want the amount, right? Not a difference, but they want, a how much. If that's what they're asking for, then what you do is, the simplest way to do it is to go to your one sample t-test, and instead of comparing your scores to the previous years in order to get the difference, you want to basically compare your scores to 0 in order to get the amount. It's kind of the same way, like if you were measuring somebody's height. If you wanted to know how much taller are they than last year, you find that notch on the wall and you compare them to last year. If you want to know how tall they are, you compare them to the floor, right? The floor is 0. So in this case, we put 0 in there, and we make sure that we have that whatever confidence level we want, in this case 95. And when you put in 0 and you hit OK, now what it's done is it's basically done the work for you. So the mean difference is 76.2. Notice that is exactly 65 points higher. The upper level, the upper bound is 81.26. Again, 65 higher than the previous one. So it literally has taken your confidence interval and just moved it up 65 points. So that's why you can actually do that. It's not that much of a kind of thing to do just in Excel. But again, it's there, you can do it. So if they're asking again for the amount, like in the homework, how smart, what's the IQ level of students today, that's an amount. You would want to compare it to 0. If they're asking you how much higher is the IQ scores today than in the 1980s, how much higher is self-esteem now than it was last year, you got to put in that comparison number and it'll calculate out the difference for you.
Okay.
Yep.
That makes sense. Thank you.
And that is your confidence intervals. So those 3 confidence intervals, the single sample, dependent means, independent means, those are the 3 that you will be asked to do. And you will also have to identify which is the correct one. So it'll be like exam 3 where you have to figure out what is the description, which one should we run, and then the only extra thing is, do they want an increase or do they want an absolute amount? And then you run your confidence interval.
would a good thing to before, like, would you give that number in the problem?
Yes.
And then if we see that number, then we know which to put that value in and not 0, or we trick us and number it, but actually you get that.
I don't think I will trick you,
Okay.
but at least not intentionally. I mean, I proofread these things, so. But the easiest way is look at the question that's being asked. If it's asking for a difference, this has to go in there.
Mm-hmm.
If it's asking for an amount, you put in 0.
Got it.
Yep.
Okay.
All right. So is everybody good on ANOVAs? How to do those? How to read the post hoc table as well?
I am.
Yeah. Cool.
So good.
Nice.
Thank you.
Yeah. Well, if anything else comes up, let me know. We still got tons of time, but yeah, I think everybody here seems to be in good stead. See a lot of nodding and not lost forlorn looks in the eyes. So good.